Okay, example 5. The base of a right cylinder 10 feet high is shown. Find the surface area of the solid. Dimensions are in feet. Okay. Now, here's a problem that sometimes students have. They don't read the problem. They look at the picture and they make an assumption about what the problem is. Hey, look, there's that. I'm supposed to find the area of it. They can see the word area there. They just skim the problem. They see the word area, so they find the area and they just are done, right? This says find the surface area of the solid. And the first thing you might question if you're just skimming through the problem, you see the words surface area and solid, you might look and say, it's not three-dimensional. There's no solid there. But then, if you look, it says the base of a right cylinder is shown. All right? That's just the base of the cylinder. That means the person in the book didn't want to go to the trouble of drawing a three-dimensional picture with that as the base. It would actually look kind of like a mailbox, if you're interested. It'd be a big mailbox, 10 feet high, but you know. But it has kind of the shape of a mailbox. It has like that rectangle with the semicircle, and it comes out like that. So if you want to visualize what it looks like. But again, all they're doing is showing me the base. So if you notice here, I want to find the surface area of this big mailbox. The surface area of any cylinder or prism is 2b plus pH. That's the formula. Okay, that's the generic formula for any generic figure. If you want to get more specific about specific figures, you can come up with a specific formula for a cube, a specific formula for a circular cylinder, that kind of stuff. But this is just the generic one. It happens for all of them. We have a base that has an area and a perimeter. And we have a perpendicular height. Okay. So these two dimensions here, the base and the perimeter, both come from that guy over there. Okay, so if I'm doing a problem involving a three-dimensional figure, that's what I'm going to draw on my paper, is the two-dimensional base. Because I have to find the area and perimeter of that thing. I also have to know the perpendicular height of the cylinder, which, oh, it's 10 feet, by the way. Usually when they draw just the base, they tell you the height within the words. If they draw the three-dimensional picture, a lot of times the three-dimensional height's on the picture. Sometimes it's still in the words. All right? But again, I need to find these three values. So here's what my paper looks like for a surface area problem. I usually draw the base. If I have to look up the formula, I'm going to write the formula down on my paper. If I don't have to look it up, this is something I would leave off. If I know that off the top of my head without looking it up, don't worry about writing that down. I do write down B equals P equals H equals. Then I start identifying this stuff. Okay, I might even start with the height. The height is 10 feet. That was easy because I just looked and saw it. All right? Know that this height here is perpendicular height of the solid. It is not going to be on the two-dimensional base. It's not going to be 6. Height's either going to be sitting in the words, or if they have this three-dimensional picture drawn like this one, it's going to be on the picture like that. It's not going to be part of the base. It's going to be how far the bases are apart from each other. All right. As far as area base is concerned, we have a semicircle and a rectangle. Okay? The rectangle is 5 times 6, which is 30, right? That's how big this space is. As far as the semicircle is concerned, the area of the whole circle is pi r squared, as Braden mentioned earlier. How much of a circle do we have? Half of it. So it's pi r squared. So pi times r squared divided by 2.
Is that 28.26?
That's 28.26, but then divided by 2 would be 14.13. Yep.
What did we do with the very first one we did earlier? We did pi squared instead of...
We did the radius squared times pi, which is all you hear, radius squared times pi. Before it was a radius of 4, 4 squared 16 times pi. Okay, now it's 3 squared 9 times pi.
We didn't divide by 2 on the last one.
On the last one is a full circle.
No, I'm talking about like the very first one.
We were finding the circumference. This is the area.
Whole circle?
Oh, okay.
Oh, I see. Oh, you're talking about this one.
Yeah.
This is, we just did pi times radius because we were looking for the length around.
Okay.
If we were looking for the inside, we'd have to use a different formula. All right? Sorry about that confusion. All right, so going back to this, drawing you back in here, we're trying to find the area, how much space is inside. So it's pi times radius squared over 2, which Kaylin said is 14.13. Okay, so the area of the base is the rectangle and the semicircle put together, so it's a total of 44.13. That's square feet. Now the other thing we have to find is perimeter, and this gets back to what Braden's concern was just a minute ago, is what's the perimeter of this thing? And perimeter is how far around it is. So if we need to find the length of all the sides, the length of this side is 5, the length of this side is 6, the length of this side is 5, the length of this side is the radius times pi. Okay, so 3.14 times 3, which is 9.42. Right? If you don't know what 3.14 times 3 is, do it by hand, do it with a calculator. If you do it enough, it just sticks in your brain like mine, and I just know what it is. All right? But again, perimeter of the base is the other thing we need to know. Add up all the sides. 5 plus 6 plus 5 is 16, plus 9 is 25.42. That's feet. This is what surface is and always will be. You find a whole bunch of stuff, area of base, perimeter of base, height of solid. You find all that stuff using whatever formulas or procedures are necessary. Area is using formulas, perimeter is more procedural, add up all the sides. Height is inspection, you just find it somewhere in your problem. You find all that information out. Once you've identified all three of these numbers, then it's simply a matter of applying the surface area formula. Surface area equals 2 times b plus p times h. It's a multiplication, and an addition, and you do it in that order. Multiply first. 2 times 44.13 is 88.26. 25.42 times 10 moves a decimal point 1 space to the right. Add those up, you get 6, 4, 2 carry the 1, 4 carry the 1, 342.46 square feet. In that case, they only asked me for the surface area, so I just did it. If they asked me for both surface area and volume, which they could have, volume would be b times h, right? This times this would be 441.3 cubic feet. I would want to identify that SA equals then B equals. Again, if you have to find more than one thing, identify your answers. Okay. If they only ask you for one thing, don't feel like you have to identify it as much. You can put the proper units on it though.